Write the major product of the following reaction, and the reaction is given by the starting material information. The reactant information is provided for us in the compressed form. From the compressed form, if you write the zigzag form, it becomes very easy for us. Hence, it becomes a task for us to convert the compressed form of molecule into the zigzag form. So, therefore, in the zigzag form, this is methyl connected with the CH associated with double bond, followed by this is connected with CH. This CH is also connected with another one CH, followed by it is having two methyls. Look at here. This is the carbon having one hydrogen connected with two methyls. Similarly here this is CH, one H followed by connectivities, one with the double bond carbon, one with the double bond carbon. So therefore this is not there. At this only we have to write the methyls over here. These are the methyls. Look at once here, carbon, 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 double bond and double bond, C and C matches. This is the CH, where here two methyl groups are present. This is allowed to react with whom? HBr is our reagent. Here also the same situation. This is acting as electron rich. This is pi bond containing system. As being it is maintaining pi bonds, it behaves as what? Electron rich system. This is electron rich part. This is electron rich system. Whereas in this HBr, our reagent, HBr is present in the form of some part of time it is present, otherwise majorly it is present in the form of what? H plus followed by Br minus. H plus is having vacant orbitals, Br is having 4 lone pairs of electrons. As being it is having vacant orbitals, it is acting as electrophile. So one particular component of my reaction related component, that is starting material, is electron rich, whereas other one is what? Electron deficient, that is electrophile. Electrophile initiates the reaction because it needs electrons. Those electrons are very much heavier there at the starting material. Whereas the name of the compound, if you name it 1, 2, 3, 4, 5. 4-methyl pent-2-ene is the name of the compound. Whereas here our electrophile H plus will initiate the reaction. If you initiate the reaction with the H plus when comes nearer to that of the alkene system, this pi bond electron density is donated towards the vacant orbital present on the H plus. Now there are two chances. This is secondary carbon, this is also secondary carbon. Out of these two secondary carbons, whichever becomes more stable, that particular carbocation formation generally takes place. But in this case, if you look at, if hydrogen is connected over this particular one, this also becomes secondary carbocation. If hydrogen is connected on this particular secondary carbon, this also becomes secondary carbocation. But this particular carbocation, if it is formed, that is, if hydrogen attacks over this particular carbon, it is having more number of alpha hydrogens. Hence, reaction takes place in such a way that here it is having two methyls. Our H plus will be connected from this carbon and it will generate carbocation, because it is having 3 alpha hydrogens at this end. With this connected H plus, it is having 2 hydrogens. So therefore 5 H plus ions are there. 5 H plus hydrogens are present at the alpha carbon. 5 hyperconjugative structures are present. The maximum number of hyperconjugative structures are present under these conditions, hence it forms. This is the relatively more stablest carbocation formation takes place. On this, our nucleophile, that is Br minus, makes an attack over here. As a result, here on the carbon, this is bromine, followed by this will be CH, and here what only? That is tertiary carbon is present. Like this, product formation takes place. This will be Br. So write Br very nearer to this to identify this one easily. There only one carbocation formation takes place. The formed carbocation is stablest carbocation. There won't be any kind of reason for it to undergo rearrangement. Hence it continues in its stablest carbocationic state. With that stablest formed carbocation, it involves in further participation in the reaction and is getting attacked by the nucleophile. Thus, as a result, it is converted as the corresponding product.